In this section, I will look at different ways to monitor the performance of your system. When looking at the performance of a system, it is important to have something to compare it with. This is often referred to as a baseline. In this video, I will look at some of the different Windows performance tools that come built into Windows. These include the Task Manager, Resource Monitor, and the Performance Monitor. Next, I will look at data collector sets. Once you decide on what to monitor, data collector sets allow you to group these in a collection. If you so choose, you can use the pre-existing collections or customize them to meet your own needs. Lastly, I will look at the Reliability Monitor. The Reliability Monitor tracks how stable your system has been. This is a great tool for seeing how often a system has crashed and what software was installed when the system started crashing. With Windows, there are a number of troubleshooting and performance tools. The most common one is the Task Manager. The Task Manager is used to get a quick overview of your system. This is a very commonly used tool when troubleshooting and often the first troubleshooting tool used. Using the Task Manager, you can terminate a process if it becomes unresponsive. Next, you have the Resource Monitor. The Resource Monitor expands on the features of the Task Manager but provides a lot more detail. The Resource Monitor also includes hard disk information, something the Task Manager does not have. Using this information, you can determine which process or processes are monopolizing the hard disk. When the hard disk becomes overworked, this can cause every service on the computer to experience performance problems. If you require even more fine-tuned information, you can use the Performance Monitor. The Performance Monitor allows you to analyze your computer's performance in real time. To do this, there are hundreds and hundreds of counters to measure different aspects of the computer system. With the Performance Monitor, you can also save the results for later use. The results file can even be transferred to another computer and read there. Without further ado, let's have a look at how to use these tools to monitor performance. First of all, I will look at the Task Manager. The easiest way to start the Task Manager is to right-click on the taskbar and select the option Start Task Manager. The Task Manager will show you any applications that are running on your server. Currently, there are no applications running on this server, but there is always software that is running on any computer system. If I select the Processes tab, I can see a list of processes that are running. The Processes tab will show me how much CPU and memory are being used by each process. One thing I would like to point out is the description field on the end. In older versions of Windows, there was no description field, and just using the executable name alone made it difficult to know what each particular process did. If I select SVC host, for example, the description for this item is host process for Windows services. This executable provides a bootstrap to a Windows service. If I right-click on the process, I can select the option End Process if I wish. If you have a process that has become unresponsive, you may need to end that process. If I select the option Set Priority, I can change how much priority Windows will give the process. A word of caution here. If you give the process more priority than normal, for example, assign it above normal, high, or even real time, the system may start becoming unresponsive. The process may run faster, but it will do it at the expense of all the other processes on the system. In fact, once you make the change, you may find it very difficult to change the process priority back or end the process. Generally speaking, I only ever lower the priority of processes. I hardly ever raise them. Since this is a service, if I select the option Go to Service, I will be taken to the Services tab. You can see that the two highlighted services are linked to that process. If the process linked to these services were to stop, these two services would also stop. You will also notice the status column. The status column tells you if the service is currently running or stopped. On the Performances tab, you can see some graphs relating to CPU and memory use on the system. At the bottom, you can also see some statistics relating to memory use. The first one, total memory use, tells you what is the total amount of RAM that is in the system. The next one, Cached, tells you how much of this RAM is being used to cache files. Keeping files in memory after they have been read, or caching, improves system performance. The available statistic tells you how much RAM out of the total is available to software running on that computer. The last figure, free, is a little misleading. This tells you how much RAM you have that is not being used by the system for anything. I have a system with 6 gigabytes of RAM that had a very low free value like this one. The system was used for video editing. Even though the video editing software was not using much RAM, Windows cached all the video files into RAM and thus left very little free RAM. This is a good thing. What this means is that Windows is using all the RAM as efficiently as it can. When trying to decide if you need more RAM in your server, look at the available statistic. This will tell you how much RAM Windows can use if it needs to. If this figure gets too low, the system will start paging. If the system starts paging, the performance of your system will deteriorate. The Task Manager gives you a general indication of how your system is running. If you want more details, you can run the Resource Manager. The button at the bottom here will launch it for you from the Task Manager. On the Overview tab of the Resource Monitor, you can see the 4 parts of the Resource Monitor. These are CPU, disk, network, and memory. If I select the CPU tab, you can see a lot of the same information that was available in the Task Manager. You can see on the right-hand side there is also an additional graph that shows how much the CPU is being used by services. On a computer running as a server, being able to break down the CPU usage between applications and services is a great way to determine where the load is coming from. On the Memory tab, you can get a breakdown of how much of each type of RAM each process is using. For example, how much shared RAM the process is using. Shared RAM, as the name suggests, is RAM that is shared between many processes. The biggest feature that I like here that is not available in the Task Manager is the information on hard faults per second. As you can see, the column here shows how many faults the process is causing per second. You will also notice, down the bottom right-hand side of the screen, a section on hard faults per second. A system that is doing a lot of paging will have a lot of page faults. This generally occurs when the system requires more RAM to operate and compensates for the lack of RAM by using the hard disk as RAM. Using the Resource Monitor, you can work out where the page faults are occurring and possibly make adjustments to the amount of RAM that process or application is using. Depending on your environment, you may move the application to another server. Needless to say, if your system has a lot of page faults, you should consider adding additional RAM to the server. On the Disk tab, you can get a lot of information that is not available in the Task Manager. If you are having a lot of performance problems, this tab gives you a great deal of information about which processes are using the hard disk. I have seen a system in the past where the CPU usage was very low, but response time was also very slow. Looking at the Resource Monitor showed that the backup process was the top process in the disk activity section. The backup should not have been running during business hours, and thus it was a simple matter to start it earlier in the night and thus solve the problem. If your system is doing a lot of paging, the page file will generally end up being near or at the top of the list with the most reads and writes. This tab also gives you the graph of disk queue length. This is the number of processes that are waiting to write to the hard disk. If your queue length is too high on a regular basis, you will need to install faster hard disks or add additional hard disks. Adding additional hard disks adds more read-write heads and improves the performance of your server. When adding more hard disks, consider moving applications, which generate a lot of hard disk activity, onto separate hard disks. Doing this will separate disk-intensive applications from the other applications on your hard disk. The last tab is the Network tab. This tab gives you an indication of how much data is going through the network card on your system. A lot of this information is available in the Task Manager. However, you can also get additional information on this tab. For example, the TCP connections that are currently open, and also which ports are currently accepting connections. When you are troubleshooting poor performance on a server, generally CPU, memory, disk, or network will be causing the performance issue. Upgrading the poor performing areas will generally improve system performance. If I now close the Resource Monitor and go back to the Task Manager, you will notice the Networking tab on the Task Manager. The Networking tab does not give you all the information that was in the Resource Monitor, but I like to use this tab to give me an indication, when server performance is poor, of how much data is traveling over the network card. If there is a lot of traffic, I tend to open the Resource Monitor to determine what kind of traffic it is. The last tab shows you which users are currently connected to the server. If I had another administrator connected to the server via a remote desktop connection, it would appear here. If I wished, I could disconnect or log off a user using the buttons at the bottom. If I now close the Task Manager, we can move on to the next tool that is great for looking at performance, the Performance Monitor. I can start this from Administrative Tools under the Start menu. To access the Performance Monitor, expand down through the Monitoring Tools to Performance Monitor. The Performance Monitor works by measuring counters on your system. You can add a counter for almost anything on your system. To add a new counter, press the green plus at the top of the screen. As you can see, there are hundreds of counters. If you have DNS installed, you could track information on the number of DNS requests received. If you are using replication, you can track how much data is sent over your links. Microsoft used to require that you memorize certain counters. However, it seems in recent years they only require you to have an understanding and familiarity with the counters available. If I expand memory, I can select a commonly used counter like available MB. This will show me how many megabytes are available on the system. If I were to run the Performance Monitor all day, I could track how much RAM is available on my system as load changes throughout the day. Another popular counter under memory is page faults per second. This will give me a good indication as to whether or not I need to add additional RAM to my server. If I now scroll down and select Physical Disk, you can see there are a lot of counters in here. If I select Percentage Disk Time, you will also notice that I can select an instance. This allows me to subdivide the counter into smaller parts. In this case, I will select the C drive. There is only one hard disk in this system. However, if I had multiple hard disks and wanted to track a single one, I could do this. You will find that most counters have many different instances. For example, if this were a network card and you have more than one network card, you could select the individual card. This brings up the question, what is percentage disk time? If I select the tick box Show Description, I can get a description of what the counter is measuring. Sometimes it is very difficult to understand what each counter does from the name alone. The description really helps to explain what the counter is measuring. If I now add this counter, I will have a graph of all the counters I just added. Remember that each time you add another counter, this does put additional load on your system. Also remember that the more counters that are added to the graph, the more difficult the graph is to read. If I right-click on the screen, I can save the settings. I will save the settings as a baseline. If you are always measuring the same information, it is helpful to save the settings into a file. Once you have decided on the counters that you want to use, you can use them in our next topic area, Data Collector Sets. Data collector sets are essentially a collection of counters that are bundled up to make measuring system performance a lot easier. Windows Server 2008 comes with some predefined sets to make it easier still. Unlike the Performance Monitor that measures data in real time when it is running, data collector sets can be scheduled to run anytime. You could, for example, measure the performance of the server once a day or once a week for an hour. This would allow you to have a history of the performance of the server as time goes on. Once the data collector set has run, the data captured is placed into a report. This allows you to quickly and easily navigate through the performance history of your server. This makes a data collector set great for creating a baseline and generating ongoing statistics. A baseline is a record of the performance of your server. The baseline should be created when the server is first installed and put into production. The baseline allows you to compare performance from when the server was first installed. In business, baselines are great when you are trying to justify new equipment or upgrades. Imagine, with a baseline you could say, with confidence, that memory use on your server has doubled in the last 6 months and is likely to keep going up. Giving these statistics to your management helps justify a RAM upgrade. Let's have a look at how to use data collector sets. I already have some performance counters from the previous demo which I can use in a data collector set. To do this, right-click on Performance Monitor and select the option New Data Collector Set. This will launch a wizard to transfer the performance counters to a data collector set. The wizard is quite straightforward. Just enter in the name of the data collection set, I will call it Baseline, and then select a location in which to save the data. Once I have pressed Finish on the wizard, the data set will be created using the counters from the Performance Monitor. The new data collector set will be created under User Defined under Data Collector Sets. If I select the properties of the baseline data collector set, there are a lot of items I can change. A lot of the options are self-explanatory, but I feel the most noteworthy part is the Schedule tab. If I select the Schedule tab, I can add as many schedules to the data collector set as I like. First of all, I need to set a time at which to run this data collector set. In this case, I will make it 3 o'clock, and I will run it only on Wednesdays. Running data collector sets puts some load on the server, so I only want to run it once a week so I can get some ongoing statistics to help justify a new server around budget time. Notice that I can also set up an expiration date. When set, the schedule will cease on that date. I will set this for 2 months. If you do set up a schedule, it is also useful to set up a stop condition. In this case, I will set the stop condition for 1 hour. Without a stop condition, your data collector set may keep running. Under the Limit section, you can set what will happen when a limit is reached. When I select the Limit tick box, the data collector will be restarted when a limit listed below is reached. For example, you could have it time-based, but in this case I will select a maximum size and set a value of 10 megabytes. If you are worried about how large the data collector set data file may become, you can set this value. If I now exit the properties, you will notice that there are some data collector sets that have been predefined. If it was on a domain controller, there would also be a data collector set relating to Active Directory. If I select System Performance, this data collector set is a collection of common counters used in judging system performance. To start the data collection, right-click the data collector set and select Start. You will notice the little green arrow on System Performance showing that the data collector set is running. If I now expand down into the Reports section, you will notice a new report for the data collector set has been created. The process takes 60 seconds to measure data about the system. Once the 60 seconds are up, the report will be generated. Different data collector sets will capture data for different time periods. You will notice that at the top is a quick overview of how your system is doing. If, for example, Windows thought that you needed more memory, the status light would be red. If you want more details about your system, you can scroll down and there's an almost endless amount of information about your system. Microsoft went to a lot of work to try and identify the common counters that are used by a majority of administrators. In a lot of cases, it is a lot easier to use or modify an existing data collector set rather than use Performance Monitor and allocate all the counters that you require. Also, data collector sets allow you to track additional information that is not available in Performance Monitor. The tools shown so far are great at showing performance, but these tools don't tell us anything about how reliable the system has been. To do this, you can use the Reliability Monitor. When troubleshooting computers, it is useful to quickly get a history of a computer and its problems. The Reliability Monitor tracks changes that happen on the computer, For example, the adding and removing of roles and software changes. If your computer starts to become unstable, you can see in the reliability monitor what happened around the time the computer started having problems. To help determine how reliable a computer is, the reliability monitor introduces the System Stability Index. This is an index that rates a system from 1 to 10. If a system crashes, the rating goes down. This includes blue screen errors, software crashes, and software hanging. If the system is performing well, the System Stability Index goes up until it reaches the highest rating of 10. The System Stability Index is placed on a graph and plotted against time. Using the graph, you can quickly determine that, as soon as a particular piece of software was installed, the computer became unstable. Let's have a look at how to use the Reliability Monitor. By default, the Reliability and Performance Monitor is disabled on Windows Server 2008. On Windows 7 and Windows Vista, it will be enabled by default. To enable it on Windows Server 2008, first of all, open Regedit. Navigate to HKey Local Machine, Software, Microsoft, and then down to Reliability Analysis. Under Reliability Analysis, there will be a folder called WMI. In the WMI folder, create a new DWORD called WMI Enable and set the value to 1. Once you have added the setting, you will need to also make a change in the Task Scheduler. Close Regedit and then open Task Scheduler from the Administrative Tools under the Start menu. From the Task Scheduler, expand down to the folder called RAC. The scheduled task is in here called RAC Task. This is the task that is run to collect data for the Reliability Monitor. This task may be called RAC Agent on some editions of Windows. If the task is not displayed, right-click on RAC and select the option Show Hidden Tasks. If you have a look at the task itself, you will notice that the task status is ready. Even though the task status is not marked as disabled, the task is in fact disabled. Let me explain why. If I right-click on the task and select Properties, and then go into the Properties for the task and select the tab Triggers, you can see what events trigger this task. The first trigger runs the scheduled task when an event is logged in the event log. The event is generated by the Customer Improvement Program, so unless you set Windows to participate in the Windows Improvement Program, this trigger will never be activated. The second trigger you will notice is disabled. In order for the task to appear as disabled in the Task Scheduler, all triggers must be disabled. If I select the option Edit at the bottom, you will notice I now have the option to enable this trigger. Once enabled, the task will repeat every hour. In order to have some data for us to look at now, I will right-click on the task and select Run. Depending on the system, it may take a few minutes to run. I will accelerate time so we don't have to wait for the task to complete. Once the task is complete, I can run the Reliability tool. To do this, I will go back to the Performance Monitor and right-click on Monitoring Tools and select View System Reliability. On some systems, Reliability Monitor may be listed as a separate item under Performance Monitor. You will notice that the system started off with a Reliability Index of 10. On this day, Windows is reported as not being shut down correctly. This is possibly the power being pulled out or a hardware fault. On this day, you can see there were also a number of crashes on the computer. You will also notice that on that day, some software was installed. This is what makes Reliability Monitor so useful, as it matches software installs with system crashes. You can see after the install, the system crashed every single day. You can see that this kept the Reliability Index from going back up. On the next day, some updates were installed, and the Reliability Index started to go back up, and the crashes appeared to have stopped. If there are no more stability problems on the system, the Reliability Index will continue to go up until it reaches 10. When troubleshooting computers, and you want to know the history of the computer, it is well worth opening the Reliability Monitor to see what has been installed and when the problem started occurring. In summary, remember to create a baseline of your newly deployed systems. It is best to wait until it goes into production to give you a good idea of how it is going. I have seen administrators take a baseline of a server after they have installed Windows. Taking a baseline of the server with no load on it and no software tells you nothing. The baseline is useful 6 months down the line when you want to compare the server performance now with what it was back then. With the systems I have shown you, use them to find any bottlenecks in your system. When these bottlenecks are upgraded, your system performance will increase. One of the most common bottlenecks is memory. When you do not have enough RAM in your system, Windows will start using the page file on the hard disk. This will really slow your system down. Upgrading the hard disk will not help, even though you may look at your performance tools and see that the hard disks are working really hard. To fix this, simply add more RAM. If you find that your hard disks are working hard and the page file is not listed near the top of the list of most reads and writes, you may need to make changes to the way that your hard disks are configured. To fix the problem, add additional hard disks or a RAID array. Moving a disk-intensive application onto its own disk away from the operating system can improve performance. If you find that your CPU is the problem, add additional CPUs or upgrade the CPU. When looking at performance graphs and data, think about what is causing the results that you are seeing and think about what is normal. A highly accessed database server is going to have a lot of activity on it. It may be quite normal for the CPU usage to be over 80% and quite acceptable. However, on a server running terminal services where the users want quick response time, you may not want the CPU usage to be over 50%. For the exam, have a good understanding of each of the tools and when they should be used.